All right. Welcome everyone at the next multi-networking community saying. Today is April 3rd, and today we are going to discuss the DRA stuff, so how we can integrate. And I think, Lionel, you're first on the docket. Are you okay to do the demo?
Yeah, sure. I have some
Let
slide also.
Oh, perfect. Let me make you co-host, and you can share then screen. Let me stop sharing. Stop share. Go ahead.
I think you can see my screen now.
Yeah, it's on. Yeah.
Yes. So I made a network DRA demo based on the KubeCon comments and all the discussion that I could hear and I could contribute or be part of during KubeCon. I made it. I mean, I'm not an expert in DRA. I made this just to learn about it and how it works and what components are involved in Kubernetes. The first part is about the controller, but it's I mean, for me there's two parts in DRA. There's the controller part and there's the driver part. And the controller part I will not cover it in this demo because it's about scheduling the pods and stuff like that. And I think it works well and it's what is I mean this is needed in the multi-network initiative, but I'm not talking about that. I put a link to this presentation from last year. I think it's interesting. Probably there's more. So I will send a slide after that, and you can
And
read more about that.
if I'm not mistaken, there is a lot of changing coming to all this. I think the last year's version is kind of getting rejected. That's why the beta didn't went through. So if anyone can add to this, but if I'm not mistaken, this is going to get quite heavily redesigned.
It's not like that. It's what is there are fundamental things that can be redesigned. That, for example, all the opaque thing with CRDs and all the stuff that is very opaque, because that breaks autoscaler. So the effort is in making the scheduler happy, but
Mhm.
the mechanisms and most of the internal parts, I don't think that they're going to be redesigned. So the important thing and the important for the network is the idea is to have qualitative and quantitative uh, parameters so the scheduler works and assign the correct thing to the network and avoiding all these opaque CRDs and CRs and indirections. That's the two fundamental parts that there is controversy with the today.
Right. Thank you, Antonio.
Yeah, thanks. And yeah, I saw this new way, but I haven't really looked into. And so my part is more about the driver. And Antonio, you demoed a similar thing using device plugins maybe a month ago in the SIG network meetings, and that's the part I've been focusing on, and that I try to reproduce using the DRA and work around these networking things. So I created this flow diagram to see where which component are communicating with which other component and which one we have to develop, which one are in Kubernetes or in Containerd, etc. So I wrote this DRA network DRA plugins that implements this DRA API. We could check after that how it looked like maybe. And where you have to implement this node prepare resources that is called after the node selection. So the node selection to me is the controller. So the node has already been selected. The kubelet will ask to prepare the resources to the kubelet plugin, so the DRA plugin, and it will send the claims to your DRA plugins, where you have to prepare it and to I mean to in this case it's to write this CDI file. So where you can CDI is a container device interface where you wrote file in a specific format that will edit your container when containerd will try to when containerd will create the container. We will see this in a few slides. So your network DRA plugins will write this file. In my case, it's just a simple file that will add a hook in the container creation, and the hook will call a specific path, so a specific program with some specific arguments. So in my case, it would be the CNI config, some network attachment specs. And once you wrote this file, you have to return to Kubelet from the DRA plugin. You have to return which CDI device files you have created. So Kubelet will send it to containerd with the container runtime API on the create container call. And then containerd will read this file, will build the OCI container spec, and will edit the spec based on this container edit in this CDI device config file. And then after that, containerd will create the, or will call the create function in runC, and then runC will call the hook program. This is, I mean, this is not so important, I would say, but it was for my understanding, and I think it's good to know a little bit about that. And at the same time, when runC will call this hook program, it will pass some parameters. It will pass the the arguments, so the CNI config and attachment that we define in the CDI device file, and it will pass also the OCI state, and the OCI state contain the container ID. It contains some bundle directory where you can find the container configuration. It contains some annotation also. That's what I'm using. So the annotation in contain, it's containerd. What this annotation can contains the sandbox pod, the pod sandbox ID, the pod name, pod namespace, and more. This is important information, because when you have to prepare the resource in your network DRA plugin, so when the kubelet on the first bullet point, when kubelet sends the node prepare resource call, you don't get the pod name and pod namespace and pod sandbox ID, etc. So you get this information at that stage. So the next step is not mandatory. It's me who created it. So it's a callback to the DRA plugin, because the network DRA OCI hook is just a program that is run by runC and containerd. So I would lose all the logs and stuff like that. It was easier for me to debug and troubleshoot if I was doing it this way. The hook is calling a server in the network DRA plugin where I can logs and I can troubleshoot in an easier way. And then also about troubleshooting, if your hook or the program behind is returning an error, the only way to have it would be in the pod events, or like pod describe. It will show an error, and it will describe what's the error at the end. But I feel it was easier if we have all the logs in the network DRA plugins both. And
one thing. These are the things that are now broken, right? And this is related to all this training. And this is the things that we can bring to the discussion, to the container runtime, and to the node people, to say, look what you are having to do to get this. But if we have this feedback, it's going to be easier to articulate the discussion with all this ecosystem, right? Because they know how we are solving the problem, and they are going to see this and say, okay, we are making your life miserable. So that's what I'm saying is we have a clear use case, just focus on and then we can bring a solution based on that to simplify all these. I don't know how many things are going back and forth here, right? To say, okay, we can propose to remove this to just doing 2-3 API calls, but we are going with something, with a real use case and a solution that is working and an improvement. So that helped us to lead this discussion.
Yeah, no problem. But I think that, I mean, this is quite complex, yes, but I feel that there is also other improvements. I will talk a bit later about the other improvement that I believe it has to be done. And the last part is this create runtime server that have to first get the pod spec. So in your example, Antonio, you are using the bundle directory, the config file, but we can use the cry API to get, I don't remember it's called, get pod sandbox ID or something like that. So we have to get the sandbox ID in the network namespace, etc. So we can create a network the network attachment at the end. So using KNI or CNI. In my case, I use the Multus SIG API, but we can use any API at that stage to add the interface in the pod. And the last part would be to report the status of the CNI call, for example. And this is where I was blocked, because there is this resource handles allocation results in the resource claim, but this has to be set by the controller. So before all this kind of things is happening, so before the DRA plugin is aware of anything that has to be injected in the pod, the status should already be there. And this is another problem that I met. But it's just to do in the demo, and I haven't found any solution or good solution for that. So for the demo, this is what I will demo. I will deploy.
Just a question on the previous one. So do you expect the DRA controller to update the pod spec into whatever it's been reported when the attachment is being created? Or at least if you have some ideas, because that's something where, sorry guys, Musin, my name, I'm working at Ericsson. I've been following multi-network for some few months. Unfortunately, I didn't have the possibility to join earlier. And I've been doing some reading on the level it's required at least to start the discussion on the array and the multi-network, looking at use cases and on a very high level, no deep analysis. So I'm trying just to see how the multi-network, when it comes to networking type, IPs, endpoints, and all of that, could eventually be.
Let's I would like to go through Lionel demo, and our next bullet is exactly about that. Let's discuss, let's see what Lionel did, what he managed to achieve. And then one of the gap here already he pointing out, like the pod status needs to get updated by something. And yeah, we need that all. That's like the core. We need pods to contain all the IPs of the names of the namespace, not only the current default interface, right? So that's something that we need to propose and move forward on what to do about that, right? Because and yeah, we can talk in 5 minutes. Go ahead, Lionel.
Sure, understood.
Yeah, thanks. And yeah, it's also a topic that I will bring. It's only 2 slides. Now the demo is, I will deploy a pod that has a resource claim. And I created this, I didn't create the network attachment definition, but the network attachment, I've been inspired by Multus because Multus is the project I know the most. And in Multus, you have this annotation where you have this network selection elements, and you have a list of them in your annotation when you request a network attachment. So I created the same thing, just I created a CRD for that, where your resource claim has the param ref to this object. And this object in Multus is referring to the network attachment definition, so I kept that. The pod B, demo B, sorry, is referring to the same resource claim. It's just to show that the demo B will not.
Is the network attachment already existing, or are you creating it?
I created the network attachment.
Okay, cool.
Yeah. Yeah, the demo B just show that we cannot have another pod pointing to the same resource claim, so it won't be scheduled. And the demo C is just to show the resource claim template. Yeah, the demo. So I have.
Can I have a question to Previous? So that shows that resource claims you want to a pod, but template, I assume demo B can point to template, right? With C.
Yes, it could be.
Okay.
Because yeah, I will show.
Okay,
I will
perfect.
show the template. So I have a kind cluster with. Oops.
Capital A. That's the same as capital A. Dash capital A.
Namespace. So I have a kind cluster with the DRA plugin installed with the DRA controller. I have only two nodes to control the controller plane, the control plane, and a worker node. I have Multus, but it's used for the Multus API and for the object, the network attachment definition. And I will deploy demo A pod. So this we deployed the demo A, which has maybe again I will show you the demo A pod. So it is this pod that has a resource claim, one resource claim that is also referred in the container. We will talk a little bit about that later, and it's referred to resource claim that is this one, and this resource claim has to refer to the DRA driver or the DRA controller that is installed in Kubernetes. And
so what is the DRA networking? Is the name of the controller? What is does that name matters?
Yes. So yeah, I forgot to mention that in the presentation. Sorry, but this is the DRA driver that I developed. So it's when you will claim a resource, you have a kubelet plugin that is registered with that name.
Mm-hmm.
So
okay.
The kubelet will call the correct DRA driver and correct DRA controller. Mm-hmm. So it can do this node resource allocation, etc. And then you have this resource claim that points to the network attachment. So this is a new object that I created. And it's a bit the same, as I said, as the Multus annotation. Mm-hmm. So it refers to a network attachment definition, and it contains the interface, but it can contain the IPs, the MAC address, etc. So this I would say represent the interface, and this represents more the network itself.
Mm-hmm.
So we have this pod that has been deployed and that is running. If we execute in that pod, and we see that there is this net1 interface, we have an IP address because in the network attachment definition, I have this host local IPAM, and it's a MAC VLAN based on ETH0. Yeah, I have no way to show that, but yeah, this through the process that I showed you before, the interface has been created in the demo
And
A code.
you do still run CNI in the background, right? After all this.
Yes. So in my case, where is it? Yeah, here. In my case, on the 8, I use Multistick API that
No,
calls
that's
CNI behind.
that's fine. But basically, after this whole thing is done, the default CNI still runs as well.
Ah, yes. Yeah, I haven't touched the default network.
Yeah, and that still runs. Okay, yeah, but that's okay. That's another gap right in here.
Yeah, exactly. I mean, it's a bit more too complex for what I
Yeah.
want to learn.
No, that's fine. Yeah.
What do you mean exactly? I mean, CNI is a choice. You can run CNI or you can run whatever you want.
No, but I want to run only this.
Yeah, okay. Then just plan by a dumb binary that returns IPs.
It shouldn't be just dumb. It should be properly defined, right? That's not be just.
But the thing is,
Yeah, let's continue.
why-
Antonio, we can discuss. Let's discuss about the gaps that we are seeing after the demo. Okay. Go ahead, Lana.
Yes. So that was for the pod, the pod demo A. We have the resource claim also. Network MacVLAN ETH0 attachment. Here, so we can see that it is reserved for this pod A, and the controller has defined on which node it has been scheduled.
And so this resource claim, this is the one that this is what we are pointing in the class in the pod spec. Yeah, is that right?
Yes, exactly. Yes, the pod spec point to this resource claim. The resource claim points to the network attachment. It's written the network attachment definition. Okay, maybe I didn't consider the kind. I think I considered only it's mistake. Sorry, but the network attachment, it refers to the network attachment, and then the network attachment refers to the network attachment definition.
Oh, but that's why that's what I was kind of missing. But because I saw exactly you pointing to definition, but in the code you're pointing to the attachment itself and then to NAD.
Yes, yeah, mistake from my side. So sorry.
No worries. No worries. It's a demo.
You have a status there.
Yes.
Yeah, let's.
This is a problem, I believe. But I will show you just after the demo. And it's very short demo. The demo B is just to show that we have a demo B that points to the same resource claim, but the pod B will be pending because the resource claim is already allocated or claimed. So it says that resource claim is already in use, no new claim. The last one is just to show the. So the last one is to show the templates. So when you have a template, you have multiple resource claims that are created, one for each node, each pod. Sorry, and if we check the pod, I deployed 2 pods, so one for each. And then behind the object that is pointed behind is the same network attachment. Yeah, it's the same network attachment here.
Can you bash into the C demo? Exec into it.
Sorry, you want to say this?
Exec,
or?
Yeah. Inside demo C. I would like to.
Okay. Yeah.
Exec into pod C.
Yes.
Oh, it has a. Oh, because it's a demo. Oh, it's a deployment. Okay.
Yeah, it's a deployment. Yeah.
Got it.
So it will get a new IP with net1, and then those are pods.
Just to check my understanding, there's a resource claim for the second interface. There's no resource claim for the default network. Is that right?
No, yeah, that's true. Yeah, that's another gap, right? That's not consistent, right? Because
Yeah,
ETH0 is not handled by the array at this point, right? It's basically what we are doing today with Multus, right? That's something that needs to be changed, right?
But I believe this way is okay. I will show the last slide that I have.
Yeah, go ahead.
Yeah, I mean,
because
I think this is great. I'm just trying to get my head around exactly how
Yeah.
it works. It's a good step along the way.
Yeah.
when I started this book, I was thinking that we can update the claim status using the DRA driver, and this is the point that I wanted to tell you, that if we could do that, we could add the IPs, the MAC addresses that have been assigned for this for this resource claim for this pod. So we could return this IPs, etc., all these resources inside the resource claim itself in a common format. Maybe, I don't know, maybe there would be an API or something like that. But apparently it's not the case. It's what I discovered when I did this demo. Because the resource claim status is set by the controller. So before the OCA hook, before the CNI cores is done, the status is already there. The other point that I would like to mention is that I haven't checked the pod deletion. I don't know how it works, but what I know is that there is no hooks, for example, in the CDI or in the OCI spec. For the network attachment, maybe it could be an object in Kubernetes. I'm not sure, because I feel that we had the same object in the cap, that we had this network that had this reference to another network object that was a bit more generic, and inside this network object we had the interface name, we had if it was a default network, etc. And the last thing is the claim, the scope of the pod resource claim, because at the moment it's a container thing. So the CDI devices is also a container feature. So I saw some comments on Slack saying that it was a bit old, and I think I have the same feeling. So I put an example why it's a bit strange, because if you have two containers, which one will claim your network attachment? And it was a whole that I had.
What if you want
I wanted to show.
To be able to take it? If take the today, right, when you have a network attachment, any pod can attach to that network.
So that's I think another aspect of on this particular thing is that a container can would get access and needs a specific identification when it's a path, right? Net device is part of a namespace, and it's not a path, and then everyone shares it across, right? So that's the difference, right? And then it has to be on a pod level versus go ahead.
Yeah, I was going to say, at the moment, DRA is container level. I actually had a conversation with Patrick Goley about this a little while ago, and he was saying it could be extended to allow pod level objects. It's just not a thing that's been done. So it's an area where there's a gap, but it seems like a relatively small gap. At the moment, it does look a little strange.
The field is there on the pod level. So basically, it's just how we can treat it. And basically, instead of explicitly saying, oh, this container is going to use it, if it's not there, we maybe this special type of claims can be treated as, okay, they will be assigned to pod. Nah, you have a hand, sorry.
I think I was going to lower my hand. Patrick covered it out. I also had a discussion on the same things with Kevin, and they are agreeing to change that constraint for network specific, to make it a pod level versus a container. There's also a DRA working group going. John has started, is going to create one. He's started the process, and they are going to take a few of the requirements from the networking side from us on the similar lines. Yes, I agree. It cannot be on the container. We also have the same requirements to be on the pod. Networking is on a pod level. So this is a great demo, Lionel. Is it on the 128, or I'm assuming the DRA definition, right? Not the
I use Kubernetes 1.29.
one. Okay, because in the 130 DRA is where they have started to make named resources based DRAs definitions to make the scheduling better.
Okay.
Uh,
Yeah, the scheduling, I haven't looked into it, but I saw you posted some links with the old versus the new way, but I haven't checked so much about it.
Okay, no worries.
Yeah, I think the two main points to me was this pod resource claim being inside a container, and the second one was the status. If we have a common way to report the pod IPs, MAC address, etc., we could have our own implementation of the services, and it would be. I mean, this is the biggest point, I believe.
Yeah, I agree with you. And all right, anything else, Lionel? We can then jump to the other. If anything else to your demo.
No, I will. Yeah, the link is on the document, and I put some reference.
This is really awesome. Thanks for doing the experiment.
Yeah,
shows that we can work with that, and I assume this is what Antonio showed last time as well with the SIG networking. The one kind of comment to here is in multi-networking to kind of very explicitly say that, call that out. Because for this group, what's the most important part is the API part, not the implementation. And this is the implementation, the usage of the CDI and all those mechanisms for plugins. This is something where I assume Michael, you step in with K9 or some sort of agreement on how we can work with combined DRI with multi-networking. But from our point of view here is to identify how we can modify the APIs to work with networking, and then the rest can kind of follow, right? Just want to make sure that that's the main focus of this discussion here is the APIs and how we would use them rather than under the hood. I appreciate, Lionel, you doing that. I don't want to kind of depreciate what you did, but from this group, what I care most is how you use the APIs, right? And what gaps in the APIs there are, right? Definitely, that's the main thing that we need to address in this mission, in this discussion, because our API was on our CAP was only about APIs, not about how you implement the things. All right.
Moshe, just for clarification, when you mean about the API specification, you mean everything in the ecosystem that is related to the networking part, Kubernetes, API, objects, and so forth.
That's true. Yeah, that's correct. How, because main thing is move away from annotations, right? Today's all the multi-networking Multus is using annotations. Wherever Google does, we're doing annotation as well. We need to move away from that aspect. B, status reporting. That's another aspect. How we get the IPs from all the pods. We should not rely again on annotations, right? That's something something we want to kind of improve and have a standardized ways on doing things rather than non-standardized, right? That's what I'm calling out. And I don't want to push anyone's kind of way of doing it. It has to be open. So you can use Multus, you can use anything else, foobar, whatever implementation you wish to do, you can do that, and it should work for you. So it should be abstract on the ways of how you want to do it later on, right? So is that any other comments on this?
Just wanted to comment that I wanted to show the full path because of this container problem that
no, and that's perfect. Yeah, and that's one thing so one thing that I read through a bit of the DRA that the kind of changes for the pod spec that's the first thing I caught as well, right? There is they treat claims same like volumes, like this is the same pattern, right? You have a volume definitions first on the pod level, and then you select the containers and you define inside containers which volumes do I want to use for that specific container. and they follow the same path, which for networking, for the default networking, you don't need. You do need that on the other hand for example, SROV case, right? Any SROV use case, this is where you have to specify to a container. I'm not sure whether, unless we can do something, come up with something better. But I know I'm not a specialist on the paths, because like and I'm referring to here to DPDK type of workloads where I don't care about net device. I care about a path to the physical hardware, which I can then use in my user space application, right? Via, for example, DPDK. In this case, I don't think there is any other way to go around this except for, yeah, this container will be the main one that will has the user space application and need that SROV device in it. Any comments to that? Is there other way? Can we improve on it? That's my question.
On SROV, I mean, you just use what you have today, right? It's you point to virtual function or the physical function. And
But are you not using the file system as a handle? You need a handle down to the hardware, and that's a file system, and that's where the container comes back.
yeah.
Yeah, so I don't think we can jump over that, right? So that's I think, yeah. So for that one, definitely we still need the same. DRA on that note is good because it already has the container level, and for those devices that will handle it and be treated as such, they can treat that one, right? But otherwise, to what we discussed, like all the net device type stuff has to be on the pod level, because it's kind of unnatural to assign things, especially when you can you would be able to assign them into multiple containers. What would that mean? That's kind of a no-op operation, right? Let me get back to sharing the notes that I have so that we can see. So the first thing that I captured from all is the status update. What Lionel, you pointed out. What we proposed is to have a status on a pod, an expand pod spec. So Antonio, you mentioned that this pod, the status can be on the claim. That's something that's not usable. Keep in mind the pod IPs today, the only reason I would want to have that is to create endpoint slices, right? Unless we change endpoint slice controller to leverage and work based on those resource claims, I'm all fine with that. But if not, then we need to have something in pod. And I would assume we want to do it on a pod because this is less objects than resource claims, right? Because resource claims you will have per interface, compared to pods, it's an aggregate, right? So that's something that's, for that one aspect, something that we need to make sure that pod status can be updated with all the pods IPs belonging to the pod, right?
But that doesn't meet the stories that they hear. Or the people say these network interfaces are attached to external networks. If they are attached to external networks, then point slice controller doesn't have to do anything there, because it's not going to install a queue proxy in the external network.
Not
No,
really.
but in this case, but in my no, that's not true. There's multiple cases where it's important and needed, right?
But that's the cases that are not clearly spelled. I didn't find these cases that this interface doesn't connect to an internal network.
The multi-tenancy calls it out. The
multi-tenancy is not a core. Multi-tenancy is only a qubit use case. That's not a strong use case for Kubernetes.
I think, Antonio, I don't want to call out on what is the strong use case or not. That's a use case. I agree, maybe that's not valid in terms of popularity, but that's something that multi-networking kind of was focusing on, and we want to have that kind of capability. If we say that the only way to do multi-networking is through just as a side, and basically we don't integrate at all with what we have today, then there is no point of us doing anything, because we can just same way stack with Multus as we are. Because that's what we have.
I'm not saying anything. Multus doesn't have nothing to do. What I'm saying is there are different use cases. One is multi-tenancy in Kubernetes. Other one is connecting interfaces to external networks. So
And both need to, you use both wants to, in both cases, you want to know what is the IP on the interface.
Exactly, but with one, the external one, you can use claim status and create UR and get the IP.
No, and that's perfectly fine, but still Kubernetes has to know, because let's say I want to create a service in front of that interface. Why not?
But that's the thing, it's external network. Services is for internal network.
How? No, that's not true.
That's how it works, Magic.
Services
an internal IP.
Antonio, services to expose your workloads outside to other stuff, or aggregate the workloads.
Cluster IP is internal. It's specifically, we have
That's fine,
internal
but
traffic
load balancer
policy.
type is not. Load balancer is not.
But load balancer type is published as status IP, ingress IP. It's an external IP.
Exactly, and that's what which we want, right? We want to.
But you can use gateway for that. That's what I'm trying to say is.
Okay, Antonio, I'm not saying, and perfectly fine using gateway for that. I agree with you, but then I still need to have a standardized way to do it. I cannot have one interface, let's say the default one, done through endpoint slices, and then the additional interface is done through gateway. That's not acceptable. We cannot have here for this one create a service, for that one create a gateway. What's the use case of that? There's a bunch of
external versus internal. External versus internal.
This
has to be clear.
No, that's not
there is difference external versus internal. A lot of difference.
Nah, go ahead.
Yeah, sorry, to interject. Masha, I also have a confusion where when you're saying you want to have a service in front of these external interfaces, you mean Kubernetes service?
So what I'm referring to, and this is something that I agree with Antonio, not exactly, we don't have to use services. I mean here, because that's where Antonio goes directly to, but service like object, and we already, I think, agreed on that for multi-networking, we can leverage gateway API, but I want to have a load balancer VIP in front of my pods that are on different interface, or in front of the backends which are on the other interface.
That is fair. But the load balancer the front end of the load balancer will also come from that external network only, right? That will not.
Yeah, but I want to define that, right? On how I go into those back endpoints, right? And I want to leverage Kubernetes endpoints discovery on what are the endpoints on that secondary interface, right? Or even if I want to change that, right? I want to run my pods only on that additional interface. And this is where, again, I'm bringing up multi-tenancy, where my other interfaces are running on the other on the other network, or even easier use case that we can do today, where I can create my pods with multiple interfaces, and the default gateway is set on the other interface, so that it's easier, right? And that other interface, I want to set up service-like capability, right? And let's say it's going to be gateway API to use that, but then let's commonize, because I don't want to create a gateway API, use gateway APIs for those interfaces, but then I use service for the first one. Why the inconsistency, right? If I were to use multi-network, I want to use gateway API for everything, whether it's the default first interface or the last. That's kind of what I'm saying here. Did I answer your question, Neha?
I mean, I'm understanding it, but that would I see that as a really big change in the Kubernetes orchestrations to now understand these external resources. These are all
in what form, Neha? What do you mean?
Like in form where these external interfaces which are coming from external tenant, external network, Kubernetes resources, they don't understand these external devices, right? What these external devices they're attached to, like what these external devices they're linked to.
Why do you need to know that?
Why do I need to know that? Let's say if I create a load balancer, let's say I construct a new resource, not Kubernetes service. Let's say I can construct a new resource, Kubernetes external network load balancer, right? Now, my Kubernetes controller should also be aware of these external devices, where they are placed, and they need to be aware of how to allocate an IP for this load balancer from this external network, external network, right? So VAP
So
Patrick?
let's assume you would have Metal LB load balancer. Are you familiar with Metal LB?
Yes. Sorry, no,
So
I'm using
Metal
Meta.
LB basically does stuff based on ARPs. The L2 mode. There is BGP mode and there is L2 mode. The
Mhm.
L2 mode basically what it does is it's and I'm gonna explain that one because it's maybe simpler, but Metal LB works based off of services today, and that's something that maybe could be improved and work based on some gateway API route, L4 route there, right? And it will understand that I have some VIP, right? So Metal LB, how it works is the VIPs unfortunately have to be in the same L2 domain as your node interface, right? And let's say we have those two interfaces on your per each of your node. And the second interface is its own subnet. So at that point, if you have a request going to the specific VIP on the secondary interface, your router of that secondary network will send an ARP request who has this VIP, and Metal LB will reply then, and it will attract that packet into that node that has that VIP set. And this is what Kubernetes does today anyway for even the default interface, where as soon as you get that packet into the node, then your CNI or whatever your networking capabilities are for the Kubernetes pods should then redirect that packet into the backend pod, the right backend pod, right? On the right interface though. And for that aspect to redirect from the node to the pod, this is where we need those endpoints and awareness of Kubernetes, what IPs are on each of the pods. And this is how basically I'm kind of explaining how the default interface works, because the endpoint slice controller does that and aggregates all the IPs for the default network. I would like to achieve same capability for the additional interfaces as well. Did that kind of give you some?
Yes, partially. Did you say Meta LB?
Metal LB, metal like M.
Okay,
Yeah,
Meta
metal.
LB. Okay.
Yeah, this is open source project. You can read on. Just give you an example of how this could work, right? That's what I'm. That's
Got
what
it.
we basically we were trying to do here. And I agree, service. As even team in Chicago had a talk about how bad service API is, and I agree that's not something that I would push towards to get, and I think we all agreed on that. But
Correct.
gateway API is some gateway for us to go there. But I want to have it standardized. I don't want to have two ways to define services for depending on what network you're on, right? I think Moshin, you were second from hand.
Yeah, no, just must say thanks. No, just to lift up, I'm aligned with your reasoning because that's one of the questions when I raised about the API spec, which of course, apart from what's happening with the pod spec and the workloads and so on, we need to make sure that at least my current understanding based on the cap is that we need the pod or the status populated with the multi-network and the extra interfaces, but at the same time the whole endpoint and endpoint slice and the discovery, because that's an important connection towards the Kubernetes services, which is of course the standard way. You need the services to select a set of workloads and which of the endpoint to be selected as well. So I'm aligned on that, and that's the reason where maybe there will be work of like how to complement from a multi-network the networking aspects that are specific and not really connected to the claims from the DRA, at least to my understanding. Maybe I'm lacking the full end-to-end of the DRA, but there will be something either CNI and then later on the natural mechanism, either we extend with new controllers. I don't know, but just to say we are aligned on that. It's important the endpoint and slices as well. Yeah.
Yeah, exactly. That's Per, you have a hand. You're muted if you're speaking.
Sorry. And anytime anyone says changing services, I get scared because there's so much semantics in there. At the same time, what's good is, right, a pod doesn't specify anything around the default network today. But while I agree with you, it would be nice to have the same way of specifying everything. I think the chance of going into changing the current service specifications and the current default networking, it's just a losing proposition.
But that's why I'm saying we would not. And basically, this is where Gateway API comes in help. This is something that we discussed a few weeks back.
I like the gateway too, but I think we have some simple. I mean, we're gonna have a list of questions that we'll have to be able to answer, like just simple things between two networks. Can you expect connectivity? I would say it's undefined. It could be connectivity, or it could not be connectivity.
And this is something that I did call out, and we did call out in the all those things were called out in the KEB because it's up to your implementation how you want to do it.
But I mean, so if I have two networks today, the only thing you know on the default network is like there is reachability between all pods.
Yeah,
that's basically the only thing, and then there can be filters that stop you from reach it. But when we because since there is no network orchestrator and we don't plan to make one, and I don't think that's the right decision. I think there's some simple rules that needs to be defined. So we talk about external load balancers. Then the only thing that you can be expecting to work is load balancing over the networking you're talking. It might work in certain system to call through another network, right, and so on. But I mean, be careful with the semantics and leave it open then for specific implementations to fill in what's
and that's the point, and that is the kind of assumptions that we have on our current KEB. There will be just calling out all those.
I know. But same thing. I think around this with services and how to integrate that with the multi-networking. I think it's going to be, unfortunately, have to leave a lot of space for the implementations.
So, to be honest, Per, that's something that. Like, I think the biggest problem with Gateway API is cluster IP. This is something that cluster API, backup, a Gateway API even struggles today, right? To how do we implement cluster API? Because that's I think that you think that's the first one and the least complex, but it is the most complex because with cluster API comes DNS. And in cluster DNS, and that's the hardest part.
No. And so we have the discussions before, right? Is a net? I mean, what is a network? L2, L3? Do we have different types and so on? How do you give enough room to be able to be both, right? And so on.
Yeah.
So I mean, when looking at the resource definitions, there's definitely something I see us using at Kaloon, but I mean, it's fairly complex. So for having a normal user using it, I agree with you. So I think we need to come up with some abstractions on top that makes use of this. And come up with an example then sort of, if I have today, specify a network, what does the resource sort of example of that doing? I mean, how do you make resource claims? That should be sort of, you have to add in new resources then all the time, every time you can start a new pod when you want to attach to a network.
Yeah, that's where I think we're gonna move to the next. We can move to the next bit because that's exactly another aspect of this, right? I would consider if we were to move to DRA, it should be able to handle the whole thing for us, right? But before we go there, is there other comments on the pod status for the IPs?
Yeah, I mean the philosophical. I mean, with many interfaces, we're looking at IPv6. The number of addresses that can be attached to a pod is then in reality, I wouldn't say boundless, but it can be large.
Yeah.
And sort of, does it make sense then to assume that Kubernetes has to know about all these endpoints? And it should be possible to set it up so Kubernetes knows it. But if you don't, we have addresses that comes and goes, right? So what is the semantics around the endpoint and the addresses assigned to pods? What is the scope that have to be known in? We start talking about link local addresses. I mean, we're going to say the same address in many places. How do we expect the APIs to handle that, right, and so on? So I think
no,
there's a lot of
but
thought
Per, you're going into areas that should be handled by the implementation and should be care about the API. Why API should care about that?
If you have link local addresses, right, then the API on the other side needs to be able to handle that.
API
No, but then
defines semantics.
Yeah, exactly.
Sure, and that's
API
perfectly
define
fine.
semantics.
So this is something where we said in the pod status that specific IP belongs to specific network, and that's the semantic. IP belongs to not cluster, it belongs to specific network, and that's a semantic where if your implementation supports overlapping, go ahead and do that, but basically IP belongs to why not?
Core. Because that's not core.
That is
I mean,
fine,
the user has to know what happens when there is an IP. There has to be some expectation with that IP. The thing
and
is
that's
that
perfectly fine. But today CNI can implement things on their own the same way, right?
And it's not conformant.
So
that's
much
why we have conformant.
To say that an address in reality is a tuple. Is network an address?
Yeah.
That's what an endpoint is here. And then sort of you can sort that into different ways to domains if you have overlapping and so on. But I mean that's the distinctions we need to make, right? That it's just not an address like in today's endpoint slice. It's a tuple. And then you need
then endpoint slice as well is a tuple, right? Because an endpoint slice belongs to a specific network same way. You should and again, this is what I would assume should happen is where we can define the semantic for how we would support the services here. And I'm not talking about just using the service word because it's what we call the object, but let's say how we do it, and I'm going to repeat, keep using the service word because everyone understands what I mean. Where a service could belong to a specific network, and then the service becomes very simple because it's what you have today. Today, a service belongs to default network. You cannot have any other way.
What's good is that we know we have working systems for many years with overlapping addresses and load balancers and so on. So it's more about defining the semantics and sort of making it work and then also be scalable.
But just to add to this, I mean, if the ambition to have these resource claims and so forth, they are with the unique identifier. I mean, each one of them will carry a resource claim name. And looking beyond that, that should be as well, whether overlapping IPs and so on, be something in the pod spec as well in the status. Every IP will have a connection to where it's been assigned, which is via the claim. And hence, later on, when you keep building the other building blocks that are necessary for the reachability towards that endpoint, because it's at an endpoint at the end, you need to reach it from outside somehow. How you're going to expose it and so forth, we can discuss. But the goal will be how we make sure it is hooked into the ecosystem. If it's Kubernetes service type extension, endpoint slices extension, but I think there is potential for the uniqueness through the claim names and so forth. It's the metadata that should be carried. I'm not simplifying. I'm just trying, to look at it from high level. What will be the expectation on the specs, where we need to make sure that they are defined. There is, and which types and so on. On that one. I mean, sorry.
So folks, no, that's fine. Thanks for that. We are at the time, we're over. Let's continue the discussion next week on if you can. I hope some of you got your own opinions on what has to change. I have my own. I listed some of what we from the demo. Let's talk next week about apologies, dry throat. let's talk about the default CNI aspect with claims. And then I think as soon as that group going to create for DRA, let's go there and let's see what we can influence over there and get to get some of those things in. All right. Thanks for that, and let's meet next week.
All right. Thanks.
Have a nice week.